much about how we go about Wolfram language, but rather is using Wolfram language as one of the benchmarking or reference that we can come to understand that actually what is the development right now in market, how far the developments and the progress of AI machine learning, that actually using Wolfram actually as one of references, then we know that actually where we are heading to and what we have achieved so far. So then we give you actually a hint actually how you could actually take on the bandwagons as a part of the technology that make available for everyone of us. Now, let's take a look about, I'll skip this part. This is about some of my portfolio. I think this, if you're interested in knowing us and see how we can work together, Desmond pass us our contact and some our portfolio later on. But rather today, I'll emphasize slightly more about, like say, from a little bit brief history about how AI comes so far and to where we are heading to. So at least we have some idea, not just in terms of globally what's happening, but we want to know what's happening right now in Malaysia market in the context. Now, this AI is something actually not something that I'm familiar to many of us. I think in early 1980s, I think many of us that if the people in the household, you notice that from freezers or washing machines, that we have something called fuzzy logics that make available. For instance, that when you put a load of your laundry into your washing machines, then if you select the fuzzy logic, some selection like automatic, you will know how much water to fill and how long is to run, and so that you will be able to not just come out clean only, but minimize your electricity consumption, also water consumptions. So this is one of the early typical application about AI in terms of fuzzy logic when come to our everyday's life. But today, when it comes to Industrial 4.0, well, people need a lot of things to be automated, optimized, and make decisions for us. So in Industrial 4.0, when it started about 11 years ago in Germany, they are talking about how to make full automation, robotics, and integration into manufacturing world. But little did people realize that Industrial 4.0 actually brought forth industrial revolution to everyday's life. And in one of the key elements this industrial revolution is about AI. And today we are here to talk about more on machine learning and predictive analytics, which I consider is a low-hanging fruit, something like what I share about fuzzy logic. Yeah, fuzzy logic, people applied it. It's not difficult, and yet it's typically applicable to our everyday's life. So fuzzy logic becomes something that integrated into our life. So same thing here. When it comes to predictive analytics, you see the screenshot here that it covers for marketing, business, economics, banking, finance, all the way engineering and logistics and operation research. And how does it do it? Now, if you look at actually whole histories on this machine learning, and it started actually as early as 70 years ago. Of course, in the early time, when people talk about artificial intelligence, people intuitively thought about robots. But this machine learning, eventually when it came to sometime 1990s, mid-1990s, it came to actually one of the dividing actually generations about AI. Why is that so? Especially in 1997, something actually quite tremendous that happens in the fields of IT, because that IBM came out a machine that actually for the first time that beat a human champion in chess. Yeah. Now the reason how it can beat the world champion is it's not because it has AI inside. Is that during the time IBM has showcased that with the advancements of the computational power and resources, for instance, in this case, that it able to pre-record about 700,000 grandmaster games in the memories of this so-called Deep Blue IBM. And in a quick calculation with advancement of CPU, it able to calculate about up to 100, 200 million moves per second, and even go as much as 20 steps onward. That means that it's not just calculate 100, 200 millions of possibility, but calculate forward 20 move forwards. So in this case, for the first time with the use of computational power and resources, it beat the world champion. This is 1997. But shortly after, about 8 years, this really AI came into the world arena that captured a lot of attentions that when it beat the world champion Go chess player with these machines called Alpha, makes it AlphaGo, not AlphaGo, AlphaGo, developed by one of the subsidiaries of Google. Ever since then, this Google, and when it proved that with this so-called one algorithm from AI called reinforcement learning, meaning that if you leave it the system to learn by itself, like a baby learning from the mistakes and the correct one, it will self-auto-correct to find out what will be the optimum path to proceed so that you will get the best reward. So as simple as a concept of reinforcement learning is one of very important, one of the most thriving actually developments in the AI field right now. Ever since 2015, it almost caught the whole world by the big wave. So now if you look at these whole developments here, now this is something interesting. I'll go and show you a quick video. So this Google since then, using the same approach, reinforcement learning, and actually put it into our traditional game. You grew up in 1970s or 80s, right? You're not unfamiliar with Atari video games. So far as I researched a little bit, and up to 2 years ago, Google had developed up to 57 actually little machines that play with Atari games that will actually beat Atari game. This is one example here, as you actually not unfamiliar with. So with the reinforcement learning here, the system will try to find what is rewarded, what is punished. So eventually, right, without even the system understand this a game, it will actually just short period of time, like 2 hours, it play like expert, just learning by itself. You do not have to guide them actually how to move, what kind of strategy you had to play. But knowing that how to be get rewarded and get punished, then let the system to further train from here, not just for 2 hours, but train it for additional few more hours. It play like a human being can never actually ever thought of. That means you could see that nearly after altogether how many hours? 4 hours of training. If the system able manage to figure out, if it dig a tunnel, just notice that how you're going to dig a tunnel on the top left side. Yeah. So you can see that this little ball eventually will go through a little tunnel here. Let it continue to play. Let it continue to play. Just give me a minute. You see that this little ball go through from behind, actually let the sit back and relax that and let the whole thing play by its own. So let's further take a look. Now, if you look at what's happening right now in this little research before I come to a real practical demo, because we want to know and to share a little bit with you all the exciting news, what's happening in the market. So then we all get more motivated about how we could be actually part of the trend, yeah, or even actually stand on top of the trend. Based on the research of 28 industries, this research was done shortly about 2 years ago. And it predicted actually in year 2025, looking of the total application, related to AI from 28 industries, right? It grossed about 126 billions of revenue in USD globally. Now, this research actually go hand in hand very well by another research by Deloitte. Of course, if we look at Deloitte, why Deloitte? Of course, those people who are concerned with the financial analysis, financial consultant, and business analysis, we like to listen to the world big four like Ernst & Young, KPMG, Pricewaterhouse, and Deloitte. So Deloitte make a similar actually predictions. Yeah, it does not look at several actually fields of industry, but it look at globally, yeah, not just in terms of AI application in IT development, but anything that industry related to AI, in terms of human resource, infrastructures, policy making, it will gross, yeah, 6.4 trillion actually in 2025. So if you look at 6.4 trillion, what kind of money we are talking about? You're talking about 6 times value of Malaysian GDP. If you look at Malaysian GDP, I'm not looking at current GDP, I'm looking at GDP before the pandemic, 2019. So you're talking about 1 year total global revenue related to AI industry is as much as 16 times Malaysia GDP. Now, if we look at AI, again, I do not want you to think about just robotic per se. Yeah, today that, like say, AI is one of the key component in Industrial 4.0. So you look at in a factories level, in today that cameras everywhere, video footage is everywhere. So we were actually using the combinations of computer vision that will make monitoring a surveillance become something that above our imagination compared to 10 years ago. What you see on a bottom right here is using a flying drone, actually doing surveillance on a group of herd of wild animals. This is not something that new in R&D. In fact, in Malaysia, I know at least there's one company using drone surveilling the plantation, combining with AI, so they can tell that among all the palm oil estate, that 1,000 acres palm oil estate, what's a growing tradition right now? What's things happening down there? Yeah, those things, technologies combining with the maturity of drone, maturity of computer visions. So AI actually go beyond actually what we actually looking just on desktop per se. It's been integrated in many aspects. I like to quote what Jeff Bezos say. Yeah, Jeff Bezos before Elon Musk is like world richest man. You know, he's a founder and CEO of Amazon. Amazon is also one of the persons that superheaded and benefited from AI in the early time. As early as 20 years ago, when Amazon rolled up one of the so-called recommendation engine, you know, AI is not just necessary to do with robot and computer vision, but things that today I like to share with you, analytics, something that you can put in as a desktop application of backend application. Same thing like what Amazon did like 20 years ago, not 2 years or 20 years ago, a recommendation engine that put in the moment you go into the website, like how we went to Lazada, Shopee, things so and so forth. You recommended you what you want to purchase next. Yeah, Amazon started that. So with that, why these things, 1 year of implementation, Amazon managed to boost nearly 30% of growth of revenue. So that's why Jeff Bezos said there's no single AI group at Amazon. Rather, it says something. Every team is responsible for finding ways to utilize AI and machine learning in their work. That means that what he's trying to say is AI should become something as simple, also as common, as something as accessible like Excel spreadsheet on everyone's machine. Yeah, it's not something like a group of R&D or computer science expert that only can understand it. Today, I have to be truthful to you. You could see that in the development, especially in past 3 years, also with a lot of new startup in Malaysia on AI, they are presenting AI as a black box. You do not actually have to go inside to understand a lot of detailed coding to, for instance, Andrew Ng is one of the major guru in the field of AI. He also offering a lot of free courses, and a few years ago is one of the most popular actually classes online, free, for if you want to understand what's neural network, deep learning, AI is all about. You go there. Also, one of his students, and this gives you fundamentals and theoretical approach what's going on with AI. But again, like I say, in the new development this day, people are offering AI solutions more like a black box this day. It's become as simple like that. You don't have to understand the algorithm that much compared to the past. It's throwing the input, you get the output. Same thing how we throw in the figures in Excel spreadsheet. You do not have to understand how Excel spreadsheet work in background. You only have to understand how you want to get the figure in and how you want to climb the figure and get a figure out. And that's just simple. So Andrew Ng say AI is a new electricity. Electricity means that one day it can manage your company without electricity, your household run out of electricity, you can't do much, right? So same thing, this is one of my favorite example I quote. Jim Gao is not something like very famous person in the field of AI, but his success story, because as ex-Google employee from a data center, you know, data center consume world power a lot. Yeah, at least about 8 years ago, all the world data center, we don't count about those people doing so-called this Bitcoin mining in a household kind of level. You're talking about those legal actually data center throughout the way consume 2% world electricity. So one of the major challenges is data center like Google is how to actually manage cut down the power consumptions as much as possible. These are responsible Jing Brown. So it's just like many of us that in the early time just went to one of the classes of AI and machine learning online. Yeah, something like what many of us were doing. We went to attend 1 or 2 classes about AI, then see how to apply it. Surprisingly, after he attended this class, he tried to work with his team of engineers. Just in a period less than about 18 months, 1.5 years, he managed to use AI technology, applied it to reduce as much as 15% in the overall consumption is data center. This is tremendous. Yeah, he's not actually an expert in AI in the first place, but what I'm trying to share is AI becomes something that if you want to reap the benefit from, you shouldn't have an excuse that you can't actually master or have no way to access that. Now, from Earth, now I'm talking to Mars, yeah? So what I need to talk about the Mars. In just last year, April, this is a historical 40-second on Mars. I would like you to see on the screen here in the center, if I point at the video going to stop for a while, but then just point it here. You notice that this little thing here, it might not looks very big on the screen, but this is a very historical 40-second. Yeah, let it continue to run. So we see that this little machine is a drone, human being first time, fly the object, something outside the planet Earth. You will see that actually the Mars is talking about nearly 300 million kilometers away from Earth. You want to remotely control something, it's next to impossible. But at the same time here, you want to fly this thing in hovering for like, this is like flying approximately, I'm not sure how high it is. I think it's just flying 40 seconds, maybe it's about 30 feet. I'm not sure, I can't recall. But if you could see the gravitational force, you still remember in your high school kind of study on science, it's one third of Earth, and the air density is only 1% on Earth. So even remote control, something like that is next to impossible. But the historical thing is now, to allow this machine to fly on its own, yeah, you need actually AI to self-surveillance, also self-navigate along the way. Just I check on the website NASA's up to like April 19. Since April 19 last year until this year, June, just a few years ago, no, 3 months ago, he had made a successful flight, at least like nearly 30 flights, along with another actually ground machines on the surface of Mars. Eventually, people did not think that much that this machine can fly that well. You thought that if it can just take off and come down successfully, it's considered a success. But now, and with a combination, of course, with a lot of research and technologies and all kind of things are built in alongside with AI, that things actually are making impossible possible. So now, if we look at again a quick understanding about Industrial 4.0 and AI, is to make all those things automated, to make itself auto-calibrated, to make itself auto-optimized, you need machine learning. Again, here, this is last slide before I come to a real demo about using Wolfram as one example, how we consider a low-hanging fruit. This chart is very important. This chart is to see that how we grow. Now, I've been speaking to a lot of actually industrial experts in Malaysia who are advocates for Industrial 4.0. Malaysian government has given a lot of grants for Industrial 4.0 since about 4 years ago, before pandemic, just a year or two before pandemic. Not many people apply, and people will get approved also. Not many of them really deeply implement it. The thing is, now, a lot of companies still actually in the era of I want operation report. Yes, true, operation report is important. The data is gold. Yeah, you need data about what is happening out there. Yeah, how many products I produce today, how many customers I serve today, and how much actually defects I detect today. All those are operation report. But again, as a statisticians, mathematicians, we want to convert into mathematical model. They describe what happened. Averagely, what is the actually defect parts we are talking about per month? And averagely, what will be the estimated actually consumption of certain some of the resources or the demand for my products, services for past 3 months or past 1 year? How's the changes in the past 2 or 3 years? Things like that. And if we know that actually can describe what has happened, we want to know why did that happen, yeah? And among all those, my bottom line, what contributed to my bottom line? Okay, maybe I look at throughput, I look at efficiency, I look at actually my defect rate, I look at all customer satisfactions. I have a diagnostic analytic, but all those things actually emphasize by looking of data that collected from the past. It's all history. The good thing is today that if you have something from the past, now we are talking about, then we could, if we can help us to see what happened tomorrow, we can do a lot of prescriptions. That's called predictive analytic to or prescriptive analytics. Now, in come the Industrial 4.0, Industrial Revolution 4.0, we want things quick and fast and correct. Yeah. We want to make sure that when you say tomorrow 2 o'clock, I don't want you to be 2:30 or 1:30. I want it to be 2 o'clock. Yeah. Things need to be as much as precise this day. So to make things that are uninterrupted, to make sure it's streamlined, to make sure it's precise, we want the system to run as a tip-top condition. So to make sure it go tip-top condition, you need to predict all the things that will happen along the way. So I will make sure things will happen according to my plan. So you need predictive analytic and prescriptive analytic. When you can predict, then you can prescribe actions. So now, how do we do that? Now I'm going to show you things in actions that, as I tell you just now, how we can actually easily make those things like how you do it with Excel spreadsheet. Now, in this case here, I'm using this, as I mentioned here. This is something called Wolfram language. It's like very established in the market for past 30 years. It's not something 35 years is not something new. Yeah, if you're interested in say, hey, how to get started? How do I try it out? How do I do it online things? You speak to Desmond, you can share with you. Yeah. Now, if I further go down here, if this is first thing here. Now, predictive actually is based on mathematical model. It's a regression. Yeah. Regression means that as simple as several points, coordinates on a piece of white paper, you try to draw a line that actually have a minimum errors among minimum errors that aligns that represent a minimum errors that from the rest of the points. That's simple regression. So things that could be, but with the maturities of all those applications and algorithm, we are able not to deal with vector numeric. We are going to deal with actually images, audios, visuals, so on and so forth. So what I'm going to show you in the first example here, simple regression model. In the background is also mathematics, but now this example here is to tell you if I have actually series of graphic, you could see here I have a series graphic. Let me put my annotation slightly to this side so it's easier to see. Now I have this graphic coming in, graphic coming. Each of the images represent a numbers. So you imagine yourself a treasure hunter. You say, oh, look at this strange symbol. Now, can I actually, in a way, interpret what these three symbols or image represent using regressions that built in as one of the advanced method of machine learning, low-hanging fruit. So immediately you can create a function already. It say, hey, these three images, the system never seen before, but based on how it calculated for above using regression approach, right, you're able to estimate, estimate. First image actually might represent numbers like 30, followed by 9 and 9. So how does it do it? Now, today I'm not here to explain theory. If you want to look at theory, there's a lot of theory available out there in the Google. You can always find. Today, I only want to share with you how low-hanging fruit it is I'm talking about. Now, similarly here, let's say that I have an XY coordinate. Now, with each the XY coordinate, right, it results into a color. It either is red, blue, or green. Three possible color, but the color actually all actually coming from a particular coordinate. This represents a XY coordinate. If I say that I have XY coordinate as, well, in the terms of machine learning practitioner, we call it features. Yeah, or you can call it as input variables. So with input variables, I have output variable in terms of color. So could I ask the system to understand this thing as if I'm asking the child to understand, hey, look at this pattern here. Now, with this thing pattern, you actually come out with a derive a method. This method, it already become model can use. Now you say that now I have two more coordinates. These two coordinates are new coordinates. I want the system right now, based on the model it generated on top, they say, can you tell me what color would that be? The system immediately gives us answer. Now on the immediately say, hey, 77% chance that'll be green color. And also similarly, second coordinate, 77% chance that'll be a blue color. It also has some other probabilities that come along with a green and red. So now the system not just give you what will be the predicted output, it will give you the chances and probabilities. So now similarly, let's go something slightly more ambitious. Say my data here, my input in variables is not in terms of graphic, my output variables in terms of string. And each time the string will actually have two possibilities. It's like in the discrete, yeah, it's either day or night. So now you immediately say, oh, Peter, aha, I know what you're going to do. If I today like have a lot of images collected from the surveillance camera or collected from somewhere that from experimental lab, I can pretty much train it and come up with a model. Then I can use it, put in the fit in a new image as if I'm teaching a child to recognize, hey, is this a male or female? Yeah, the system auto detect. By the end of this actually workshop, I share with you one example with 40,000 images, just a short training of 5 minutes, not 5 hours, using my laptop. The system able to differentiate what is a good tile and bad tile. Tile means that the one you put on your floor, the tile, which one is broken and not broken, which one is good one, or which one is a stain, a bad one, things like that. So in this case here, I already create this function called my model. I throw in 3 pictures from my kampong. I live in Klang, yeah. So Selangor. So immediately he show, oh, these pictures quite likely taken at night time. Yeah. Of course, this is like very simple. The system it learn or looking the image, some are brighter, some are actually darker. It's quite likely you can tell that which one is day, which one is night. Quite likely it's easy can tell. Yeah. 3 things. It's simple because it's like only about 30 images with that system to see. So if you want system much more complicated, how we do that? Now, those who attend data analytics yesterday, one of the important things about data analytics about data integrations. Today, if you want to make applications, right, either running a front end or back end easily, data integration, right, must be made as simple as possible. So this is something I was supposed to show in data analytics yesterday, but today I take a chance to show because it's slightly related to machine learning. Why is that so? Because I use an API called web image search. I search for happy man, happy man. I want the system to give me like 20 images from Google, who is a happy man. Of course, if you ask Google to search for a happy man, give you like 10 or 1,000 images happy man. So it immediately come like that. You see, API, this is very powerful. Of course, in actual AI, right, we do not do like this lah. But I want to show you that the integration is simple. So using the same approach, I create actually a function. I say, don't just search for a happy man in Google, but give me 40 images. I want to search for sad man, happy man, angry man. Now, you see here immediately, if I ask the system to search for that, I ask the system to also learn. I say now, I'm telling you to search for Google, happy man, sad man, angry man. And you know, these are how Google define it. Yeah. When I say happy man, it give me like all the images, 40 images happy man. But now I say those images, I get 40 for happy, 40 for sad, 40 for angry. I get total 120 images from Google. I say, can you learn? So actually, I'm telling Wolfram here, I say, based on this 120 images, right? Wolfram is downloading from the API that called by Wolfram. You see now it's downloading 40 images for 40 images. Yeah. So it take a while. It's trying to download one by one. So we let it run. Eventually, when you have 120 images, right? Just the total actually application, when you need to execute it less than 5 seconds. The system theoretically can actually differentiate quite a lot between happy, sad, and angry. So if I put in actions like this, is this man happy or angry or upset? Yeah, not easy to tell. Yeah, not easy. If you ask a child to look at the 120 faces and tell, I'm not sure. Maybe he's angry, maybe he's upset, maybe it's like something else, not sure. So these are images coming up already, all the angry men, so some even the cartoon. So you know that actually the system could be quite confused. Yeah. Quite confused. Some like throwing money, some we actually with different gestures. But in a way, we find that actually, even as simple like that, it actually doing quite well. So this is the last batch data is coming in, almost there. So let's see how we come out. One is pre-processing all the 120 images, then it will come out with application like that. Now, in the next few application here, I'm going to share with you that something much more actually interesting and in a real life example. Let me see, this almost there, almost there. It's training right now. Start training. You see here, it's doing training right now. Now, how the actually machine learning or AI, in this case, predictive analytics, how it works. In our workshops, a 5-day workshop, usually we give slightly details of the how it works. But in this case, like I say, we just using it as reference. We don't care that much about the coding. Now, in this case here, it gives a 46% chance this man is angry. 46%, it looks like happy with the eyebrow going up. Except man, like 6%. Now, again, I say this is like very preliminary. But let's say if we look at the data set, something like this. This is something like as early as Barbie doll came out with a little toy, I think 7-8 years ago. People feel amazed. This is actually part of Google Assistant or Siri offered by iPhone. It's something like that. But only thing is now our input here, we put in some text or sentences. But again, today, conversion between text and sentences, right, and voices, these are already very mature technology. If you have Alexa, you know Alexa can no longer what kind of English accent you use. Usually quite recognized quite well. Yeah, this is also part of AI. People already train a model for us. But if you can actually convert your voice into text, right? Same thing here. If I put in my text here, right, the system try to figure out what I'm talking about. Yeah, this is what's happening. So all those things you see that in 7-8 years ago, it's like you need to do a lot of few pages of coding, and even in Python this day, you need to do the same. Yeah, yes, Python has a lot of library packages built in. You need to call in and that. But for Wolfram here, for me, I find it's very useful for a layperson like you and I. I'm an engineer, I'm not IT or programmer. But to me, I still need to use it to solve my daily life problems. So in this case here, Wolfram allow a combination, a low-level or high-level scripting language approach. You can go into a low-level program like C++ kind of approach, or you can integrate with Python and R inside Wolfram. Yes, you heard correctly. You have Python and R, just copy and paste, throw inside, Wolfram will run it. Yeah, you can run in this kind of manner. Or you can run in very high level. In this case, to make use of one of the 6,000 functions that built in, you don't need to download packages, library, or install things like that. You just go inside there, quite likely you have Visa to guide you through what you want to achieve, hit on the help file, question mark, the system try to figure out what you try to do. Then quite likely you can find actually the things that you want to get. So what I showed just now here is also do a sequence prediction. If you have a sequence events happening, what next actually will come out? Is a pump? Is that rock? Is that scissor? Yeah, things like that. What's the probability? So again, machine learning actually have few level, but Wolfram have built in a lot actually algorithm, which is like very more popular algorithm in the market. So you can go inside there, say, I want to manipulate it, I want to control it, I want to configure, no issue. But usually, as I say, I'm a layperson. I don't really care that much about what's happening inside there. I just use automated mode to help me to get a result. So in the automated mode, right, immediately I can actually enjoy the low-hanging fruit for something called supervised learning, unsupervised learning, or reinforcement learning, or deep learning. Yeah. Today, of course, I'm not here to tell you too much how to differentiate between supervised, unsupervised, reinforced, or clustering, or deep learning. I simply glance through quickly. Yeah. What this happening out there in the world that make available. Now, first thing here, predictive customer analytics. You see here a few steps only. So when you want to do predictive customer, right, usually you can run away for a few examples. For instance, you want to analyze about the pattern. Does customer have pattern or not? I want to predict the behavior. To help me make decision. How should I talk to my customer? Who should I call? Who I shouldn't call? What should I offer to customer A? What should I offer to customer B? Then likely close the sales and that come to communication. What's the consumer behavior? What should I recommend to him here next? And all those things is a part of statistic, actually, predictive analytics when it comes to customer and marketing. So now I give one example here. This is like, I put my data up there in Google Sheet, yeah? So you could see here, the data actually not just actually exists in your Excel spreadsheet, CS file, text file. You can put it in, the integration with whatever data where you keep is very simple. You can keep it in a proper commercial database, MySQL database, open source, and you can can keep it in Google Sheet, and can keep it in local drive and file server up to you. So in this case, this is simple actually customer analytics. You have about 3,000 over records, small file. but I want to train it. Yeah, in this small file here, I want to see next time if I roll out a marketing campaign, right? Which customers should I actually talk to? Which customer actually should I ignore? This is very important for call center. So if I run this part here, right, immediately it runs through many replication. It is saying that I can actually achieve accuracy as much as 90%. Yeah, this is wonderful. I only have 3,000 over record extracted maybe from my customer database. Immediately I can pass to my marketing team and say, hey, I come out a model. If the next time you have customer actually your customer profile coming in, right? Or you give me your current customer profile, then I'll know which one you should call, which one you should approach, which one you should ignore. I have a 90% of accuracy. So if I want to perform accuracy check here right away, I say, hey, sure or not, you say 90%. Now, I say, okay, let's check. Give me a new fresh batch or customer name. Let's check whether you get 90% or not. Now, in this case here, for a quick check, we do not get 90%, but we get as much as actually a very good, outstanding 83% accuracy. So if you look at here, little things here, something we call confusion matrix, the system is telling here is among all the customer here, when they say, hey, you're not going to buy for me, 449. Yeah. Those who are going to buy for me correctly predict 64. And among all the actual customer, if you pass me a list, all the customer have 546, who actually you did not tell me he will not buy, but system also say, hey, correct, 449 times, I correctly guess, yeah, you will not buy. And out of the customer list 72, I correctly guess, yeah, 64 times they will buy. So I have 83% of accuracy. So if you pass me a new fresh sheet of data or customer name, I'm able to 83% of the time, I'll correctly tell you who will be the actual buyer, who would not be the interested buyer. So this actually help you save a lot of time. So same thing, how do we do that? If I have customer, actually their age, their purchasing pattern, what the consuming behavior, I say, okay, this is my customer. Can you tell me how many percent they will say yes? They say, oh, 85% this customer will say no. Better you can leave it. Only 14%. So very low chance. Yeah, don't waste your time or energy on this person for the moment. Now, when it comes to predictive engineering, this is quite simple. Actually, the whole approach is very simple. Collect data, you clean it accordingly, identify a pattern, and make prediction. So this is how actually the whole things works. Yeah, in layman terms, how it works. Behind that, there's a lot of actually advanced algorithm that automated for us. We don't care for the moment. So now, let's say today, like, as very simple thing, I have a small example here. I also keep it in my Google Sheet. This little data sheet here is not much, a few thousand records. It recorded my laboratory experiment data. Yeah, I tried to actually figure out what is a combination of data, right? Combination recipe, so I can create a cement that is strong enough to fulfill certain requirements. So if you want to make cement strong in tensile strength, maybe water, amount of cement, additive, things like that, and also the heat and moisture, things like that. Yeah. So in this case, only a few lines of codes. I train it right away, a few lines of codes only train. It's automated, it's done. Yeah. In this case, because the regression model, it does not show you accuracy, but it shows us in terms of standard deviation. You say eventually the method we should use called linear regression. Your standard deviation is 6.65. So now this standard deviation have a give us indicator how well the model is. So immediately it gives us actually a comparison chart. So it shared to us that here, you say this one ideally between what is actual, here this actual value, and down here what is predicted. If you actually have predicted correctly, the thing here is supposed to be on 4 among this straight line here, if you have correct prediction. But we know here among all the prediction and actual one, all the actually little things here, they are not too far away from the actual one. So you could see here from this upper range, lower range, right? Most actually the prediction and actual fall between this range. So it actually gives us an indicator. They have a standard deviations about 6.6, yeah, 6.6. So 6.6 PSI. It's up to you whether you want to accept it. 6.6 PSI. We know you're talking about level of confidence, approximately about 70%. Yeah. So this is some of analytics that you take a look. Now, eventually I say, okay, I want to use model. Yes. Even though it's 6.6 standard deviation, if I give a composition of this kind of recipe, the system say, hey, you're going to have a strength of 33.093 psi with the standard deviation 7.25. Yeah, this is the prediction based on this model. If I want to do some simulation, I say, can I? In this case here, in my model, I consider I accept it. I say now I'm going to play with two things. I'm going to play with cement and water using this predicted model. I adjust it accordingly. Immediately using this predicted model based on the machine learning, I can immediately play with the predicted value on the PSI. Adjust my water level, adjust my cement volume. Yes, then this is PSI, the system predicted based on my machine learning model. If I want to optimize it, I say, hey, give me a contour block. Yeah, I don't want to drag thing like this, like plain try and error. Can you actually give me a color chart? I want to see that which region, right, actually give me a highest PSI. So in this color chart, immediately it tells us, right, oh, if I actually had coming to this part, right, if I move this part, you see, I have this PSI 80, I move it all the way, oh, sorry, the darker is the lesser, the brighter is bigger. So if I move all the way here, the more to this side, in terms of water and cement, in fact, I can actually adjust my water and cement in the very optimal manner when I come to a line that crosses, let me just draw a line, yes. When I have a line that crosses this part, let me just draw this accordingly, this part, they all will have the same PSI, yeah, this region. So immediately I know I can play with my waters and cement mixtures along this region so I can optimize my combination of resources. Maybe water is cheaper than cement, definitely. So I can use more water and less cement. In this region, I achieve the same level of PSI. Yeah. So now, if you look at other things here, I quickly close it in next 5 minutes. So if you have Q&A, you can come back. Again, today, like Desmond says, we only have 1 hour, but you could see now, let me put it inside my name there. Desmond already put there in our contact, email, WhatsApp, everything, but also I put in my telephone number next to my name. You can WhatsApp me in private if you have Q&A later. If you say, I no time to ask, yeah, later you can ask me in private. Now, for this clustering, it plays a very important part in real world because a lot of time, right, we for instance here, if you put a bunch of fruits here, how are you going to actually ask some automatically sort it out? So in reality is, right, of course, if you think as simple as looking at this thing or berry with strawberry, a peach, right, easy to sort out, yeah. But again, a lot of things come with numbers. A lot of things come with certain patterns. Yeah, human being might not be easily actually find a distinction in between. So this is a time that a lot of things that patterns and behavior described in vector numeric format. Yeah. So this vector numeric format, right, it's not easy for us to differentiate. But mathematically, we have a lot of actually mature algorithm for us to help us do the job. For instance, here in this case, even though I give you a graphic like this, these are 3D graphic. Yeah, 3D graphic inside that is, wow, inside here, this scripting language can also handle 3D graphic like that. So now, this 3D graphic, I give you 8 altogether 3D cube. If you say, hey, Peter, can you help me differentiate of what are the distinction among all those things and sort accordingly? Wow, easier, not easy. You can sort among apple and orange, but you sort among these things, a lot of things that you have to actually argue about. But mathematically, if we converted these images, right, these images can be converted, can be encoded into numeric number. Yeah, this is how machine learning works. Yeah. So in this case here, the system automatically do some encoding, extract the features. I say, please give me 3 categories by 3. So the system automatically break it down. It say these 2 are to be together, these 3 to be together, these 3 to be together. Say, how does it work? Yes, inside they have a lot of algorithm built in. So what algorithm are you talking about? Yes, we have a lot of mature algorithm that the system pick up for us. I did not ask the system what to take, so the system was to choose 1 or 2 algorithms that it thinks the best to run for us. Of course, those who are familiar with the unsupervised machine learning, those methods could be not unfamiliar to you, like DB scan, spectra, and also k-means. Okay, those are usually out there market. A lot of people use k-means, but Wolfram does this automated for us. You do not have to specify which one. Of course, you could say, oh, based on this, the way how my data is scattered, right? I can force the system to choose certain method. Yes, by all means, by all means. Now, in this case, for instance, I say, hey, can you give me 2 classes, 2 categories? I don't want 3. Can. Mathematically, it automatically help you do encoding and extract the features accordingly. You say these 4 should be in the same group, and these 4 should be in the same group. This is how it performs unsupervised machine learning. You say, hey, Peter, yes, it looks fine, looks fun, but what do we do in reality? A lot of application. A lot of time that if I give you 10,000 customer list, 10,000 recipe, I say, this 10,000, they simply profile. But I want to know, are there some actually grouping as we group together? So I need to handle this 10,000 customer differently. Throw inside the system, automate do grouping for you. Then once come out grouping, then you take a look, hey, what are these people in the same group share in the same characteristic? Eventually, maybe you can figure out, oh, this group of people, they are represent people who eat halal food coming from the city. This group of people represent people who have another level of income coming from kampong who also eat halal food. There's also another group of people who are living in city who doesn't eat halal food. And with this level of consumption's ability, it immediately break down for you already. Yeah. So then you can come to a conclusion which group of people are together. So you can present, sell them different things that interest to them or to their concern. Now, in this case here, I give a quick example. This website, it contains actually a live database that actually for those people who suffer or diagnosed to have either breast cancer or people who does not have breast cancer or benign conditions. So in this case, I simply put in Excel spreadsheet. I just actually import it accordingly. Now, this Excel spreadsheet very simple. I say which Excel spreadsheet to actually import from. I just point to the file. Give me a few seconds. I just point to where the file is. Now, you see, we can create actually quite a simple things to look for actually a file that we want to import. I look for something called breast cancer. So now I have breast cancer file imported inside. Yeah, this breast cancer Excel spreadsheet is nothing much. Yeah, inside there just a column and rows. That's all. Nothing fancy inside. It's a column and rows. And we are not medical practitioner. I look at that, also don't understand what it is. I only know that one a column represent cancerous, non-cancerous, or benign, things like that. So what I had concern with, I'm today as actually machine learning practitioner or the person who entrusted to run actually prediction. This is just a few line of codes, just few line of codes. Yeah, if you go other actually packages, right? Maybe half a page, 1 page to achieve the same. Yeah, but this whole thing automated. Yeah, just like 5 lines of codes. I'm done. They say that, oh, the method you should use here is logistic regressions, automatically chosen for us. Yeah. So I say, okay, in that case, can I check how accurate that? Because the system yes can come out model, but I want to know how accurate is how true. Then now the system is surprisingly 96% accurate. That means that there's a few line of code and throwing Excel spreadsheet. It's almost like I say, it's almost like black box already this day. Now, the last example here is going to take some computational time. Yeah, the last time I ran it, it took about 6 minutes. No, I'm not going to run it. So here I have 40,000 images. But now let me share with you all where this images is. Let me switch to second screen. Now, this thing here, let me switch to second screen. Let me see if I can pull up this thing. Okay, coming up. Now I put it in second screen. Here we go. You see. Desmond, can you see my folder? Okay. Now, in this case here, I have a folder here called data tiles. Data tile inside here are positive and negative. You look at this positive file here, if I move it to be a bigger thumbnail. So this thing, I have 20,000 images. those are considered broken tiles. Yeah. Yeah, look at this. It's quite obvious, but some of the tiles is only contain stain. It's not like obvious. If I scroll all the way down, this amount 20,000 tiles here, some are not very obvious, like it contains some dirty stain, that's all. But it's considered rejected good, rejected good. So now, if we look at something called negative, yeah, negative, I go to, this is like good tiles, yeah, good tiles. Let me just switch it to medium icon. So this also contains some texture. You see, some of the texture here looks like broken, but actually it's not broken. It's like natural textures. Yeah, it's like natural coloring. So here, if you look at this 20,000 here, these images, right, it's very difficult. But now here, I'm not going to retrain again. What I'm going to do is I'm going to import the model that I previously trained. So this entire line of code is, this is a standard. You just repeat itself over and over again. So what I have to do is I say, okay, I'm going to, let me see. I put a wrong name. Let me go there and find out what's the model name is. Data tile model. Okay, this is a file name I need to import. Yeah. That's it. Okay. Done. So now, you see here, once I imported this thing, I simply throw in these three images, right? Then I say, can you tell me these three images, are they actually considered broken or consider actually they are perfectly fine? So this already I can put into a protection right away. You say first one, negative, negative, third one, broken, quite obvious, yeah? So this whole actually application, when you come to deep learning or neural network deep learning, people, only a few aspects in the world, they will go inside develop algorithm. We are the end users. Wolfram provide us a repository of all the available. If you go to website, this website, all the available algorithm, this algorithm is so powerful that actually, if I type in Wolfram deep learning repository, this deep learning repository, right, it go inside there. They had nearly hundreds over our developed proven algorithm, yeah, in the library. What you have to do is choose one of the library you want and change the input and output, and that's it. You can use it right away. For instance, you're asking you what you want to do. Yeah, are you dealing with audio, dealing with image, dealing with numeric, dealing with text, dealing with video? Let's say I'm interested in dealing with images. Then you say, okay, what you want to do with images? Are you doing that classification, data generation, language modeling? I say, oh, I want classification. Yeah, input domain images here. Now, immediately is among all the images, are you going to do facial recognitions? Are you going to use like identify main object image? And are you going to do age estimation, handwriting estimation? Or for instance, there are people who develop license plate recognition. This is common actually technology already, license plate recognition. People had that 10 years ago. Yeah, but now it's very mature. Yeah, a lot of things are using handphone can scan and recognize. All those things are inside here. Yeah, you can choose among some of the things that you find it actually you feel comfortable if just download, change a little bit input code. Like again, honestly, I tell you here, I do not develop the code. Yeah, this code here I purposely expand out for you to see a simple so-called convolutional model. That's it. I make a slightly change. If not, just one line of code, you get it from the website, and that's it. You're done. So today that pretty much I close everything I share. So again, I do not want you to feel afraid that